Calculate integral minus infinity to infinity x square upon x square plus 1 square whole square dx. Now consider the integral over c f of z dz, where f of z is equal to z square upon z square plus 1 whole square taken round a closed contour which consists of the upper half of factorial of a large circle where z modulus of z is equal to r, and the real axis are from minus r to r. The poles of f of z are given by z square plus 1 whole square is equal to 0, which implies z square plus 1 is equal to 0, which implies z is equal to plus minus iota. Therefore z is equal to iota and z is equal to minus iota are the two poles of each of order 2, but z is equal to iota is order of 2 is the only pole which lies inside C. Here f of z is equal to z square upon z square plus 1 whole square is equal to z square upon z plus iota square whole square minus z minus iota whole square. Phi z is equal to 1 upon z minus iota whole square, say, where phi z is equal to z square upon z plus iota whole square, z square upon iota whole square. Remainder at the double poles z is equal to iota is equal to d over dz of z square plus z plus iota whole square, where z is equal to iota. So z plus iota square 2z minus z square plus 2 into z plus iota upon z plus iota 4 is where z is equal to iota. Taking 2z z plus iota common, so we remain with z plus iota minus z from this term upon z plus iota raised to power whole raised to power 4, where z is equal to iota. So z to z cancel out, so we remain with iota. So 2z iota over z plus iota, we cancel out with this z plus iota, we remain z plus iota raised to power 3, where z is equal to iota 2z square upon 8z cube, substituting z is equal to iota, so is equal to 1 upon 4 iota, so equals to minus iota upon 4. By the Cauchy's residue theorem, we have integral over C f of z dz is equal to 2 pi iota, the sum of the residue within C, that is integral over minus r to r f of x dx plus integral over gamma f of factorial f of z dz is equal to 2 pi iota into minus pi upon 4, or integral over minus r to r f of x dx integral over factorial f of z dz is equal to pi upon 2. Now modulus of integral over factorial z square upon z square plus 1 whole square dz is less than equal to modulus of z square modulus of dz over modulus of z square plus 1 whole square. Which is less than equal to integral over factorial modulus of z square modulus of dz modulus of z square, modulus of z square minus 1 whole square, putting z is equal to r e iota theta. So dz is equal to r iota r e iota theta d theta. And so dz is equal to r d theta. So integral over factorial z modulus of z square modulus of dz modulus of z square minus 1 whole square is equal to 0 to pi r square r d theta. R square minus 1 whole square r equals to r cube over r square minus 1 whole square integral over 0 to pi d theta. So r cube pi upon r square minus 1 whole square tends to 0 as r tends to infinity, hence making r tends to infinity, it becomes minus infinity to infinity x square upon x square plus 1 whole square dx is equal to pi upon 2. So thus integral minus infinity to infinity x square upon x square plus 1 whole square dx is equal to pi upon 2.